All right, so for our second example, we're graphing y equals the square root of x minus 2. So noting with order of operations here, first we would square root the value of x, then we would subtract 2. This contrasts with the first problem we did, where first we added 4 to our value of x and then we square rooted. So you need to note whether or not the radical extends over the number or it ends just at x. In your calculators, how you would do that is by putting parentheses around just x or parentheses around the x plus 4 in the first problem. So now when we're picking nice values of x to put in here, I just want to pick values of x that have a nice square root. For example, 0, because we know that the square root of 0 is 0. So in my y column, I put the square root of 0, I end the square root, and then I subtract 2. So my answer is 0 minus 2, or negative 2. So now I know I have the point 0, negative 2 on my graph. The next value I can put in is 1, because the square root of 1 is 1. So I have the square root of 1 minus 2. The square root of 1 is 1. I subtract 2. I get 1 minus 2, which gives me a negative 1. The next number I'm going to square root is 4. I'm not going to square root 2 because the square root of 2 is an irrational number and is going to be hard for me to graph knowing exactly which integer value to put it at. So let's do 4 next because the square root of 4 is 2. So it becomes 2 minus 2, which is 0. Now the next value I can square root is 9. It's going to be very hard for me to put 9 on this graph, but let's just do it so we know where it's heading. I have the square root of 9 minus 2, the square root of 9 is 3. So it's 3 minus 2, which becomes a positive 1. And then we're going to stop there because that's how far our graph shows. Now I can put my points in the graph. 0, negative 2. 1, negative 1. 4, 0. And then 9, 1. So that's going to be all the way off this graph. Somewhere over here. So it's a little bit further. And then I connect my points, once again not using a ruler because the slope of my line is going to be changing. It should have this constant curve though. Like that. And once again, this end point on the left-hand side does not have an arrow because it does not go on forever. I cannot put negative 1 in there and get a real value because the square root of negative 1 is 1i, which is our complex value, so we don't put negative values into our radical. You might ask, why could we put negative values into our radical in the first problem? Well, that was because we were adding 4 to it before we were square rooting it. So as long as that negative value was greater than negative 4, we would end up with a positive value before we square rooted it. You'll notice here too, this negative 2, what has it done to our parent function of the square root of x? It has shifted it down 2 units. So our work on transformations from the fall also comes in handy here because we had our normal square root of x function and then we shifted down 2 units. So when you're working on this in your workbook, you're more than welcome to check your answer on Desmos, but make sure that you're paying attention to how long you are extending the radical over the algebraic expression underneath it, because it will either shift it to the left or right if the number is underneath the radical, or up and down if the number is outside of the radical. All right, good luck, and I'm excited to see your graphs.